Good morning, guys. Just give me 2 minutes time. Just give me 2 minutes time. I have some work to do. In the meanwhile, keep revising the topics that we have discussed. So today we'll be completing integration. We'll be discussing the properties of integrals, which is a tricky part. So ensure that all your concepts with respect to substitution are clear. Just keep revising. I'll be back. Yeah. Right. Right. So we'll get started. So we will be discussing some properties that are related to definite integrals, and these properties so we'll be discussing some properties related to definite integrals, and these properties will help us to solve problems on a faster basis. So let's try to understand what these properties are. The first property is named P naught, right? So integral of a to b f of x dx, it says that it is the same as integral of a to b f of t dt. Means, let's say you are integrating a function 0 to 1 or 0 to pi by 2 for that matter, sin x dx. It is the same as integrating 0 to pi by 2 sin t dt. They both mean the same. Okay, because if you try to calculate the end result, you are going to get the same value. Secondly, the integral of a to b f of x dx is taken to be negative of integral of b to a f of x dx. Okay, so what they are trying to say, integral of a to b f of x dx is the negative of integral of b to a f of x dx. Okay. That is, when you swap the limits, that is when you try to swap the upper and the lower limits, then the value becomes negative. So let me explain what is the meaning of this. This will give you the area made by f of x when you calculate it from a to b. This will give you the area made by f of x when you calculate from b to a. Okay, the proof is very simple. So P naught is equal to integral of a to b f of x dx, which is equal to integral of a to b f of t dt. So this is a known fact. So let's say P1 is equal to integral of a to b f of x dx. This is going to be negative of integral of b to a f of x dx. So let's see the proof for it. So the proof for this is very simple. It is something like this. If I say integral of a to b f of x dx is going to give me capital F of x between the limits a to b, then I will do upper limit substitution minus the lower limit substitution. So it is going to be capital F of b minus capital F of a. In a similar context, if I do integral of b to a f of x dx, this will be, see, since you are integrating the same function, you will get the same antiderivative. But here it is from b to a. Now it is going to be f of a minus f of b. So this is nothing but negative of f of b minus f of a. But negative of this thing is what? This whole thing, if you backtrace it, it is nothing but integral of a to b f of x dx. So this is going to be the proof for property number 1. That is P1. Next is P2 says integral of a to b f of x dx is equal to integral of a to c f of x dx plus integral of c to b f of x dx. So P2 states something like this. That is, integral of a to b f of x dx will be equal to integral of a to c f of x dx plus integral of c to b f of x dx. Means you are breaking the interval A to B into two other parts, that is A to C and C to B, where C parameter in A and B. Let us see the proof of it in terms of mathematics, that is in terms of derivation. At the same time, I'll explain you how this works in terms of graph as well. Okay. So if I take the LHS, then LHS is integral of A to B f of x dx, which is going to be capital F of x between the limits A to B. So this will be capital F of B minus capital F of A. Let me call this as equation number 1. Similarly, if I take the RHS, then it is going to be something like this. Integral of A to C f of x dx is equal to the same antiderivative capital F of x between the limits A to C. Now it is going to be capital F of C minus capital F of A. Let me call this as equation number 2. Similarly, if I take the remaining limit, that is C to B f of x dx, then I'll get capital F of x between the limits C to B. This will be capital F of B minus capital F of C. Let this be 3. Now, if I add the second and third, if I add it, then I can clearly say that f of C will get cancelled and I'll be left out with f of B minus f of A. But from 1, I'm clear that f of B minus f of A is nothing but the question itself. So this will be equal to integral of A to B f of x dx. So when I add 2 and 3, I am adding these two on the left hand sides. So this will be integral of A to C f of x dx plus integral of C to B f of x dx. So this is the proof for the third property, that is P3. I think it is P2. Yeah, third property is P2. Now we will see P3. So P3 states integral of A to B f of x dx is equal to integral of A to B f of A plus B minus x dx. Integral of A to B f of x dx is equal to integral of A to B f of A plus B minus x dx. So the meaning of this property is when you integrate f of x between A to B, it is the same as integrating f of adding the limits and subtracting the value of x, A plus B minus x times dx. This is also going to give you the same result as what this property says. So let's see the proof of it. So left hand side is integral of A to B f of x dx. I'm not disturbing it. So if I take the RHS, so this is the LHS. So if I take the RHS, integral of A to B f of A plus B minus x dx is what I'm going to take. Now what I will do is, using substitution, which we saw in the previous exercise, we know that we can substitute A plus B minus x is equal to t. So from this I will get minus dx is equal to dt, right? So I will take these two and substitute it in the question. Similarly, I know about the limits also. When x is, so lower limit, when x is equal to a, what will be the value of t? T will be equal to b. Similarly, when x is equal to b, then t is equal to a. So what will happen is integral of, in the place of a, I can replace it with b. In the place of b, I can replace it with a. F of a plus b minus x is going to be t. And in the place of dx, I can substitute minus dt. So this is the same as, see, observe, minus integral of b to a f of t dt is equal to integral of a to b f of t dt. This is from P1. What I did is I interchanged the limits. Whenever you interchange the limit, the values, the sign of that integral will get reversed. Integral of a to b f of t dt. This is from P1. Similarly, integral of a to b f of t dt is the same as integral of a to b f of x dx. This is from P naught. This is from the very first property that we saw. So from this, I can conclude that integral of a plus b minus x is the same as this value. This value is the same as this value. So integral of a to b f of x dx can be written as integral of a to b f of a plus b minus x times dx. So this is the property number. This is the fourth property, which is named as P3. So moving on to the next property, that is P4, it is going to be integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. So the proof is very simple. We know that integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x times dx. This is from P3. We know this from P3. Now, if you see in the question, that is in P4, a is taken as 0 and b is taken as a. If that is the case, substitute these values here as well as here. Then what will you get on the LHS? LHS will change as integral of 0 to a. In the place of a, I replace with 0. In the place of b, I replace with a. The function is the same, is equal to integral of the right hand side also. I'm going to do 0 to a. It will be f of a is going to be 0 plus b is going to be a and x is x only. So this is going to be equal to integral of 0 to a f of a minus x dx. So this is very simple. Here I would like to stress on one important point, that P3 is a very, very, very important property. This is the one which we use in many problems to solve them in few steps. Is there any doubt, guys? Is there any doubt?
I have a doubt in the first property, sir.
First is P1 or P0?
P0, sir.
Okay, what is the doubt?
So here x and p will be the same, right, in all cases?
Need not be. No, like what they are trying to say is integral of 0 to pi by 2 sin x dx you do. You are going to get cos x. When you substitute 0 to pi by 2, you are going to get a 0 minus 1. So you get the answer as minus 1. In a similar way, you do integral of 0 to pi by 2 sin t dt. So generally, what did I tell you in substitution method? In substitution method, when you change x to some other variable, these limits will also change, is what I told you, right? You remember yesterday's class I told you?
Yes, sir.
When you substitute and do it. But in this context, what is happening? You're not substituting. You're just replacing that value of x with some other variable. You can use y, you can use t, you can use z, whatever you want. As long as the function is the same in terms of all other attributes except that variable xyz, then the answer is going to be same. That is what the meaning of the first property is.
So, sir, where exactly will we use this property, sir?
Like how you are doing? No, you're already using
in normal substitution, sir.
No, you're not using substitution. This is not actually. This is not a property at all. That is why it is named as 0. See, integral of 0 to pi by 2. Observe this term. Sin x dx. I am saying it is the same as integral of 0 to pi by 2 sin t dt. Are you able to understand what is the meaning of this? So here the function is sine. Here also the function is sine. Function is sine, but the variable here is x. Here the variable is t. It is dx, it is dt, except that x and t, is there any difference that you're able to find?
No, sir, there's no difference, sir.
So that is the meaning. So I can say this is the same as integral of 0 to pi by 2 sin y dy also. That is the meaning of that property. So indirectly they are trying to say whether you use x or t, as long as the function and the limits are same, the value of the integral is not going to get affected.
So, sir, suppose we have a question having two different variables, sir. We can use this property.
Yeah, you can use it. It's not property at all. They're trying to say we get the same result.
Okay,
You will
sir.
get the,
And
you will get the same. Yeah. Okay. Apart from that, no other doubts, no?
No, sir.
sir, I have a doubt on property two also, sir.
Tell me.
What exactly is C here? So C is the mean value.
T is
sir,
the value.
between A and B.
If I take a graph like this, if I take a graph like this for that matter, this is A, this is B. So integral of A to B f of x dx is going to give you what? It will give you the area
Area under the curve from A to B.
made by, yeah, between the points A to B. Correct?
Yes,
So
sir.
this is going to be the shaded region. This is going to be the shaded region. Now, if I take a point C here, if I take a point C here, if I draw it something like this, then what does integral of A to C f of x dx tell us?
Area made by f of x between A to C.
A to C. What does integral of C to B f of x dx tell us?
Area made by f of x between C and B, sir.
Right. So this one, are you able to see the shaded regions?
Yes, sir.
So if I add this area and this area, is it not going to give me the total area?
Yes, sir. Please, sir.
That is the meaning of this property.
So, but what should be the value of C, sir? Is there any
It can be-
specific way to get it?
It can be anything. It's a problem dependent value. So for that problem, if you feel that if you take this value of C will be convenient to solve the problem, you can do it. If you try to
Okay.
understand one thing, but you can still solve the problem using the basic traditional method. But properties are like tools which are used to simplify the problem. When I do problem, right, you will understand things better.
Okay, sir.
Okay, you will be able to understand it. Maybe what I
Sir,
can
I
do,
have a
let me
doubt,
complete.
sir.
Please tell me.
So in the same property, are we splitting the limits, sir? Like from A to B, are splitting as A to C and C to B, sir?
Yes. See, you asked me.
Why should we split it, sir?
It will be
Can't we
easy.
not just use it directly?
You can do it. You can do it. I'll do it first. You
Okay,
can.
sir.
I'm still saying you can do it by traditional methods. See, example, since you guys asked me, the example is integral of minus pi to pi, or I will say 0 to pi. Not pi, I'll take it as 0 to 2 pi. It's sin x dx is that traditional method. Tell me. Minus cos x between 0 to 2 pi. So minus cos 2 pi plus cos 0. So it will be minus 1 plus 1, which is a 0. Correct?
Yes, sir.
So if I want to use a property number 2, that is P2, then I can write it as integral of, can I do the same thing? Can I split it as integral of 0 to pi sin x dx plus integral of pi to 0, sorry, pi to 2 pi sin x dx? You're able to understand what I did. This is what C is.
Yes, sir.
This is what C is. So why, like when you take this problem, now you try to solve and see. Okay, I'm not going to use graph for all the problems. I'm just showing you for understanding. When problems come, you'll understand why we need to use property. This is a simple problem that I've considered. I'm only just showing you the usage of it. Try to understand. So if I take this as plus and this as minus, this is 0, this is pi, and this is 2 pi. Correct? So integral of 0 to pi sin x dx, if it has area A, integral of pi to 2 pi will also have the same area A, but with a negative value. So if this area comes out to be A, this should come out as minus A, so that the final answer is still 0. You will arrive at the same conclusion. But there will be certain problems where it will be better if you split and do that function, so that you do it once, the next one will be exactly symmetric value and you can guess it and cancel it out. Okay. If I have to make it more simple, if I have to make it minus, very simple, right? Integral of minus pi to pi, sin x dx is there, right? This is there, for example. So traditional method is minus cos x between minus pi to pi. So you will get minus cos pi plus cos pi. What will be the answer? It will be a 0, right? So you did these many steps. Now how property will help is minus, can I split and write it as minus pi to 0 sin x dx plus integral of 0 to pi sin x dx. Right. So this will be A and this will be, sorry, this will be minus A and this will be plus A. The answer will come out as 0. So you're just using it as an intermediate step to solve. When problems come, you'll understand it better. Is that clear? So as of now, there are a few more properties which I will discuss and start solving some problems. Okay. Shall I proceed?
Yes, sir.
Yes, sir.
I feel it is better we solve some problems and then. No, I have to explain it. Okay, guys. So P5 is integral of 0 to 2a f of x dx is equal to integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. Integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. Okay, so this is what the property says. Okay, so let's see the proof of it. So if I take the LHS, integral of 0 to 2a f of x dx will be equal to capital F of x between 0 to 2a. So this will be capital F of 2a minus capital F of 0. So let this be equation number 1. Now if I take the RHS, integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. Now what I will do is I will take this 2a minus x and substitute it as t. Then I'll get minus dx is equal to dt. Similarly, when I take the lower limit x is equal to 0, t will be equal to 2a. And if I take the upper limit, x will be equal to a, then t will be equal to a. Right. So what will happen to this integral? So integral of 0 to a f of 2a minus x times dx will be equal to integral of 2a to a, it becomes f of t dt. Right. So this, can I write it as integral of a to 2a f of t dt with a negative sign? Because I interchange the limit. When I interchange the limit, its value changes to negative. So this can also be written as integral of a to 2a. Can I write it as f of x dx? Wait, just a minute. A small correction that is to be done. Integral of, minus dx is minus dt. Okay. When it is minus dt, then this should be plus. When this is plus, this will also be plus. So what is happening on the RHS is, I have integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx, right? This I can write it as integral of 0 to a f of x dx. I'm leaving it undisturbed. Plus this thing is there, right? What can I do to this thing? This I can replace it with integral of a2 to a f of x dx. So integral of 0 to a f of x dx plus integral of a2 to a f of x dx is going to give me integral of 0 to 2a f of x dx. So this is what is LHS. So this is another important property that we need to have in our mind. Okay. Is it clear, guys?
Yes, sir.
Integral of minus a to a f of x dx is equal to integral of did I leave any property? P6 is what I left. So I'll discuss it from here itself. See, P6 is there, right? The integral of 0 to 2a f of x dx is equal to, you can write it as 2 times integral of 0 to a f of x dx if f of 2a minus x is equal to f of x. Or you can write it as 0 if f of 2a minus x is equal to minus f of x. Okay. So make a note of this point. Integral of 0 to 2a f of x dx will be equal to 2 times integral of 0 to a f of x dx if f of 2a minus x is equal to f of x is equal to 0 if f of 2a minus x is equal to minus f of x. Okay. So why is this happening? Because from property number 5 itself, we know that integral of 0 to 2a f of x dx can be written as, dx can be written as integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx. Correct? Now, if f of 2a minus x is equal to f of x, right? If f of 2a minus x is equal to f of x, then I'll have 0 to a f of x plus integral of 0 to a f of x dx. So this will become 2 times integral of 0 to a f of x dx. Whereas sometimes you will have f of 2a minus x is equal to minus of f of x. At that scenario, what will happen is you will get the value as 0. Okay. Guys, is it clear? Is it clear, guys?
Yes, sir, it's clear, sir.
Okay. The last property that we need to see is integral of minus a to a f of x dx is equal to 2 times integral of 0 to a f of x dx if f of x is an even function. So what is an even function? F of minus x, if it gives out f of x, that is an even function. If f of minus x gives you negative of f of x, then it is an odd function. Okay. So the difference between 6th and 7th is in the 6th property, it is between 0 to 2a. The 7th property, it is between minus a to a. Negative of a value to a positive of a value will give you 2 times integral of 0 to f of x dx. If the function f of x is even, it will give you 0 if the function is odd. Okay. So having all these points in mind, can we start solving the problems?
Sir, could you explain again what was the difference between 7th and 6th? Is it because of lower limits, sir?
6th is between 0 to 2a. The lower limit should always be 0 for 6th one. For 7th one, the limit should be symmetrical. Symmetrical in the sense minus pi to pi, minus pi by 2 to plus pi by 2, minus 2 to plus 2.
Okay, sir.
That's the thing. Okay. So we'll start solving the problem. I'll start with the 31st example. Evaluate minus pi by 4 to pi by 4 sine square x dx. So if I have to do it by the traditional method, then I need to write sine square x as 1 minus cos 2x divided by 2 and then proceed. Right? Now see how the properties are going to save us. I am able to observe I have integral of minus a to a. So a is taken as pi by 4. It is of the form integral of minus a to a f of x dx. So we know this property, integral of minus a to a f of x dx is 2 times of integral of 0 to a f of x dx if f of x is even function, or it is equal to 0 if f of x is odd function, right? So this will become, can I write this as 2 times integral of, see, if I take f of x as sine square x, then f of minus x will be sine square of minus x, that is sine square x only. So f of minus x is the same as f of x. So here I am going to have 2 times integral of 0 to pi by 4 sine square x dx. So here had the function been an odd function, okay, you could have directly written the answer as 0, but unfortunately we have an even function. So we are supposed to solve this problem using the traditional method only. Okay. So 2 times integral of 0 to pi by 4 sine square x, I can write it as 1 minus cos 2x divided by 2 times dx. So 2 into dx by 2 integral 0 to pi by 4 minus integral of 0 to pi by 4 cos 2x dx divided by 2 rho. So 2 into half into integral of dx is going to give us x, and when you substitute the limit, it is going to give you pi by 4. minus half into integral of cos 2x is going to give us sin 2x divided by 2 between 0 to pi by 4 is going to give you the answer. So 2 into pi by 8 minus sin, if you substitute the pi by 2 here, it becomes sin pi by 2. Sin pi by 2 is 1. So 1 divided by 4. So you will have the answer as pi minus 1, or you'll have pi minus 2 divided by 8 multiplied with 2. So answer will be pi minus 2 divided by 4. So this is going to be the final answer. Guys, is it clear?
Yes, sir. Yes.
So let's look at the solution for the next problem. So integral of 0 to pi x sin x divided by 1 plus cos square x. So wherever I see these kind of variables like integral of 0 to a f of x dx, right? The first thing I start proceeding with is this can be written as integral of 0 to a f of a minus x dx. So this is how I'm going to write. So when I write it, it's going to be something like this. I'll take the question as integral of 0 to pi x sin x divided by 1 plus cos square x dx. The same I will write it as integral of 0 to pi minus x into sine of pi minus x divided by 1 plus cos square of pi minus x. Yes. So what I used is this property. So wherever x is there, I replaced it with the upper limit minus x. So upper limit is pi, so I replaced it with pi minus x. So this will give me I is equal to integral of 0 to pi minus x into sin x divided by 1 plus cos square x dx. So this is one property. This is one value. There's another value. If I add both, then I'll get 2y is equal to integral of 0 to pi. I'll get pi times sin x divided by 1 plus cos square x dx. Okay. So pi, if I take it out, it becomes sin x divided by 1 plus cos square x dx. Now what you can do is you can take cos x as t and then proceed. You will get minus sin x dx is equal to dt, or sin x dx is equal to minus dt. Lower limit, when x is equal to 0, t is equal to 1. When x is equal to pi, t is equal to minus 1. So 2i is equal to pi into integral of 1 to minus 1 sin x dx. I can write it as minus dt divided by 1 plus t square. So this becomes minus pi into tan inverse of t between 1 to minus 1. So if I substitute the limit, I'll get minus pi into tan inverse of minus 1 minus tan inverse of 1. So this will be minus pi into tan inverse of minus 1 is minus pi by 4 minus tan inverse of 1 is plus pi by 4. So you'll have minus 2 pi by 4 with multiplied with another minus. So minus 2 pi by 4 is minus pi by 2. So you will have pi square divided by 2 is equal to 2i. So I will be equal to pi square divided by 4. Guys, am I clear?
Yes, sir.
Right. So this is how you use properties. So you can ask me in this problem, what would have happened if I didn't use property? Imagine your plate when you have x sin x in the numerator. Had it been only sin x, I would have not suggested you to use that property. So it is because you use property only, the same problem got converted to a simpler aspect. Clear? We
Yes,
do one
sir.
last
Yes.
problem. So integral of -1 to 1 sine power 5x into cos power 4x. Rohan, I think maybe you'll get your answer now why we are using properties. If you observe this, if you have to solve it using a traditional method, it will take so much time. Whereas when you use integral of minus a to a, f of x dx, we know that it is equal to 2 times integral of 0 to a f of x dx, or it is 0. So if this is when it is even, this is when it is odd. So if I observe this function, I'm taking this function. So always whenever you have minus a to a, you need to take that function and write it as sine power 5x into cos power 4x. So f of minus x will be equal to sine power 5 of minus x into cos power 4 of minus x. Sine is an odd function, so minus sine power 5x, because the power is also odd, into cos power 4x. Okay, so this will be minus f of x. So f of minus x in this case is going to give you minus f of x. So what can we conclude? This whole thing is an odd function. So what is going to be the answer?
0.
We need not even solve this. It's a 0. That's it. Okay. So remaining problems, you keep trying. In the meanwhile, whenever I find time, I'll record and upload it in the app. You can have a look at it. Okay.
So I have a
So
doubt.
tell me.
Usually property 7 is used for trigonometric sums only, right? So
Mostly in trigonometric problems only this will help you.
So suppose we have a non-trigonometric problem, so that
You
time
can
it
use
is
it.
not used.
You can use it, no? You can use it. Maybe see. Here you can use minus 5 to 5. Here you can use. That depends on the problem. But to
Okay.
answer your question, yes, we can use it. So what I'll do is I'll solve this exercise and send it to you guys. Okay. Daily I'll try to solve whenever I find time, I'll solve it and upload the videos in the app. Just you also try it along with it, and you have any doubts, you can have a look at it. Okay, with this chapter is over. Now it is your time to start studying, and I'll conduct a test. Okay, after 2 weeks, I'll conduct a test. From Monday, I'll be starting areas, that is applications of integrals, how to calculate the area and all other things. So revise these topics and come. Okay.
Yes.
Yeah, now we can wind up this.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.